Hi, everybody. Welcome to our July Thursday. How about that heat, huh? It's summer and a great time to talk about irrigation. So our guest today, our speaker is German Barahona, who's originally from Chile, and he's been a proud Canadian since 2010. He's a BSc in agriculture engineering and a certified irrigation designer with 20 years of experience working in irrigation and water resources. And currently he works with Southern Irrigation as the designer and outside sales representative and location lead. He's also an instructor at Okanagan College for more than 10 years on the irrigation module for the viticulturalist certificate program. So you may have met him there. So I'll let you take it away, Herman. He's going to be speaking on irrigation methods and technology, considerations for establishing new and replanted vineyard sites. So very pertinent. Thank you. Welcome.
Thank you, Kate. Welcome, everybody. I wasn't 100% sure exactly how did we want to cover every single topic in this presentation. So I have a little bit of everything there. And please, everybody who is attending, feel free to stop me at any point and ask me questions about something specific that you need to know or you want to know. And also direct me in some topics that you would like to know and maybe they are not on the presentation. Okay? So just give me 1 second, please. First things, I want to thank you. I want to thank the BC Wine Grape Council and the BC Ministry of Agriculture for facilitate and invite me for this activity and facilitate to organize this. And also I want to thank everybody who is attending and taking time from your, I'm sure, busy period of time in summer, just to listen a little bit of what I can share with you. So thank you for that. So the title of this presentation, it was, and I'm going to go back there, it's Irrigation Methods and Technology and Considerations for Establish a New and Replant Vineyard. So basically, we're going to talk about what we have if we are in a situation that we are replanting a vineyard or we are planting a new vineyard. What factors from the irrigation viewpoint, obviously, should be considering to make sure that the system that we're going to develop, it's going to be successful in terms of efficiency and in terms of provide all the water requirements that you have in your crop. Okay. So I try to summarize it. There are many factors that play a role there. And actually, some of them may seem really obvious for many people, but you will be surprised how many times are overlooked and they are not considered on the planning stage of a new irrigation system for a vineyard. So I'm gonna go over, I try to just group them in a logic way so I can explain it to you and you can see how they affect this whole process and the success of this irrigation system. So the first basic factor and the first question that you should answer to yourself when you're starting a project like this is what water source we have. So in simple words, do I have water and where is that water coming from, right? Again, it may sounds obvious, but you will be surprised how many times that question hasn't been even asked when you start a project like this. In general, in BC, I would say, and specifically in Okanagan region and Kootenays, I would say, that water source, it comes from 3 or 4 different places. The more common one in Okanagan will be an irrigation district. Some of you may not be familiar what that means. It's irrigation district is an organization that it basically provide water to your property, just like cities provide water to your home. In this case, the irrigation district, they will have the whole infrastructure necessary to provide water from whatever is the source that they have, whether it's a lake, whether it's a river, whether it's a well, and they will manage and maintain all the piping, all the pumps, and everything that's required to provide water to your property. Okay, that's it's a very common way to get water, especially in south and the whole Okanagan. I would say between south and central Okanagan. And it's in a way it's kind of nice because you don't have to, obviously the user has to pay directly to them for the service that they are providing, but basically the responsibility that you have is just pay for that service, and then you don't have to worry about the details how that water get to you. The second water source common, it's obviously the lake. We are in a region with many lakes, and you may have a property that has rights to get water from the lake. So that's common water source. Could be also a regulated river or channel that we have a few of them in our region. Could be as well a deep well, which is common in some areas. For example, just to mention one, Queremíos, Custom area wells are probably the main water source that you use for irrigation projects. And I mentioned others there because there are a couple more that you may run into. It could be just a creek that you may have rights on it. And the creeks could be actually full year round running, or they could be just seasonal, and in which case you normally have some sort of a pond or reservoir that will accumulate water for the summertime. Okay, so basically the question there is, do I have water and what kind of water I have? Once you determine what's going to be your water source, and you may be asking how that's going to affect me, so I just put in an example there. The water source is going to be a very important factor actually in your decisions on what kind of filtration system do you need. If you, for example, have water coming from a reservoir, from an irrigation district, chances are that the irrigation district, it's not going to be a treat water, so it's not drinkable water. However, they will pre-treat that water, so they may pre-filtrate that water. So in terms of quality, it's going to be already ready for irrigation, and you just need a simple filter to make sure that you meet all the requirements that your emitter requires. Or if you're getting water, for example, from a lake or a river, chances are you are dealing with a lot of organic matters coming into your system. So you have to go into a more advanced filtration system like what I have here. And I'm just gonna, I don't know if you can see my pointer, but the first blue filter on the left, it's a screen filter, which it will deal with really well with well water, which it doesn't have any organics. The second one from the left, it's an automatic this filter. The third one, it will be a sun filter, and those are pretty much the three types that you will use mostly for agricultural applications. Then also, depending on what kind of water source you have, you're going to be able to determine if you need some sort of pressure regulating system in your irrigation or not. Like just to give you an example, you may have water from a gravity source, for example, that it comes with pressure already into your field. And if that pressure is more than what you really need or require for your irrigation system, you may have to install some sort of pressure regulating valve that's going to keep it in a safe level. All those questions or all those selections of those items can be done only if you know what kind of water source you have. Okay. Also, water source will be an important factor on the selection of what type of irrigation system you want to use in your vineyard. And I want to, based on these pictures that you can see here, I want to basically talk about the four more important or the more common irrigation system that you use in vineyards. Going from the left in your screen, you have a drip line, which I'm assuming most of you are really familiar with that type of irrigation because it's very common in vineyards. drip line is very efficient in terms of water application, but also because they are small emitters, they require a good filtration system, fine filtration system to keep the drippers unplugged. Then the second picture shows you overhead sprinklers, which is really common also in our area. Not only for normally you don't use it a lot as the primary irrigation system for your vineyard. You normally use it in combination with something else, so it will be more like a secondary irrigation system. So you can have drip and overhead, for example. The overhead idea usually it's that it's gonna be applying water from time to time to keep the cover crop, which it will help you in terms of make easier your farming practice in case that you have sandy soils, and also it may help you with controlled temperature as well and other benefits that you probably well know. The third irrigation system that is common to see in vineyard is the third picture that you see from the left with those blue color micro jets. Micro jets usually are confused with micro sprinklers, which is the last picture on the right side. They both basically they look similar because they are hanging down, because they are basically throwing water below the canopy of the vines. The main difference between the two, it's that the microjet, it doesn't have any moving parts. The water is just shooting it's shooting through a nozzle against to a diffuser, and nothing is moving in that unit. Versus the micro sprinkler, or people commonly they call it spinners. They have a moving part that's spinning and throwing the water a little bit farther than the microjet. Depending of your water source, which is what we're talking here, you may actually choose any of these options, or you may not be able to choose some of these options. If it's in terms of water quality, your water source is high in iron, for example, or calcium, it may develop some buildings in small nozzles like micro sprayers to the point that it may actually plug them. So it will make it really hard to run it in some areas. So going back to water source will be it's something that you really want to know as much as you can before you move in the next step of developing an irrigation system. You have to understand that I don't see your faces, so I don't know how engaged you are. If you have questions, please just ask me, okay? Otherwise, I'm gonna keep talking here. So with the water source information, we can answer, yes, we do have water, right? So the second factor that is important before you start planning, or when you are starting to plan your new irrigation system, is, do I have enough water? Because yes, you can have water, you can have a well that is producing enough water, for example, to provide all the services in a house. But if you have 20 acres of vineyard that you want to develop based on that, well, you may not have enough water for all those 20 acres. So the second factor is, what's your annual irrigation water demand? How much water do you actually need for your project? And some factors that actually gonna answer that question is, what kind of crop do you have? Different crops that you're trying to develop, in this case, we're talking about specifically in grapes, but you're planting grapes and an orchard or something different, different crops, they will have a different use of water. They may use more or less water. Even the same crop, depending on the age that they have, they may use more or less water. So you need to actually take in consideration the crop that you're trying to plant. The second sub-factor, if you want, just to answer the question about how much water we need, what kind of soil do you have in this vineyard? And normally you don't have only, or it will be really strange to have 20 acres with only one soil type. normally, even if it's in 1 acre, I will tell you that usually you have different types of soils. Sometimes they are not too different, sometimes they are significant different. But depending on that, the capacity of that soil to hold water, it will play a role on how much water you're gonna need, how often you're gonna have to irrigate here. In cases where the soil could be, it could be too sandy, for example, you may have to run irrigation more often, and you have to be really careful about the timing that you are irrigating, because there's a potential that you are wasting some water by drainage, by gravity, below to where the roots are. Versus if you have a soil that is rich in clay or silt, that soil will actually hold more water on the areas that hopefully where the roots are. So that may influence how much water you need annually. The irrigation system selection also is a factor. If you really are set to use a sprinkler system, an overhead sprinkler system, which is a good system. All of the systems I mentioned before, they are good systems, they just have different applications. But if you're particularly looking at an overhead system, the efficiency, how applies the water on a sprinkler, and there are different kinds of sprinkler, but even the more efficient ones, still gonna be less efficient than how you apply the water with drip. And that's simply because with a sprinkler, you are basically throwing the water. If it's an overhead, you're throwing the water above the canopy to the field. And in that travel time, you may have wind, it may be really hot, and you may evaporate some water. If the drops of that coming out of that stream are really small, you may actually move, or the water won't get where it's supposed to get or where you're intending to put it. It may actually fly away to another place. So the efficiency on that system, obviously, in terms of how the percentage of the gallon that you apply per minute get to the plant, it's lower than if you're doing it with a drip system, for example, which is basically dripping right directly, pretty much where it's the root zone of the plant. So probably 90 or more than 90% of the water of the gallon that you are applying is actually getting to where you want it, which is the root zone of the plant. Another important concept, which I think most of you probably are familiar with, is ETO, which is evapotranspiration. Evapotranspiration is a concept that is basically, it takes into consideration most of the factors that I just mentioned. It takes into consideration the crop, it takes into consideration the soil in a sense, well, not the soil really, but the crop and the weather conditions, the temperature that you have, the wind condition that you have in the field. And basically the ETO, what it really does, take all those factors and it tells you how much water you are using or losing, let's say, you're using in a field by evaporation and also by transpiration through the plants. So you should know that information when you're planning and when you want to know how much water you need. And also the planting spacing, which is it's important because obviously I'm just doing a really obvious example. Obviously, if you need to know how much water you need in 1 acre where you have 3 plants compared with an acre that you have 1,000 plants, obviously there is a difference in the amount of water that you need. So some of these, I put down there 2 important tools that actually are public. They are online and you can access to them for free. That they answer many of the questions that I'm putting here about how much water do you need. The first one is called the VC water calculator. The second one is called the FarmWest website. I'm gonna start with the BC water calculator. It's a really powerful tool that it was developed, I believe, by the federal government. I have a screenshot of that, which I want to show you now. This is a screenshot of BC agricultural water calculator. It's pretty much a database that you can go there. You can choose in a map the area that you are planning to irrigate. So this software is going to take in consideration the location. It has information from local weather station, so it knows the evapotranspiration that you have in that area. You can fill some fields there. As you can see, you can choose what kind of crop you are trying to irrigate, what kind of soil do you have in that area in general, and what kind of irrigation you're trying to do. And that's the software is going to tell you what's your peak evapotranspiration in that area historically. And it's going to estimate how much water in terms of gallons per minute you need to irrigate that area. In this particular example that you can see there, I select 28.3 acres, grades, along soil, and I'm intending to use drip there. And what's telling me is that to effectively irrigate and safely irrigate that field and be able to provide the water on the peak time to that field, for those 28 acres, I need 230 gallons per minute. So that's a good tool to have on mind. Again, the website, I'm going to go back. It's bcwatercalculator.ca. Try it if you have the chance. FarmWest also, it's I believe it's funded by the government, by the BC ministry, and it's a good website in terms of evapotranspiration. If you need some reference in your field about what's evapotranspiration in your area, there are multiple weather stations through BC that you can select which one is the closer one for you, and it will give you the complete historic information in terms of evaporation, precipitation on that specific area, or temperature as well. You can get it there in that specific area. So it's a good starting point if you need information about how much water you need. Okay. The third important parameter that you should consider when you're establishing your new vineyard and you're planning the irrigation is the field conditions. Obviously, every field is different. When we do classes, usually in a classroom, we always do we go in the whiteboard and we just put a square field that's going to be 10 acres or something like that. And that square field, I've been looking for 20 years and I still don't find it in the field. In reality, they always have different shapes and they are not flat like we wanted. They have topography. So basically, every field is different, is what I'm trying to say. And you have to make sure that all those particular conditions of your field are taken in consideration when you design your irrigation system. Okay, so I put here a couple of points that you have to really pay attention, and it will help you to provide the information that's required for the irrigation design. You need to take in consideration the topography of the field. Obviously, it's different if it's a flat field, which in Okanagan is not that common, versus a hillside, which is the more common that we see. The wind conditions, it may seem also hard to know it, but there are specific areas in Okanagan and in BC that they are known to be really windy, and wind could affect greatly the performance of an irrigation system. Not so much on drip, but if you're working in an overhead or micro sprinkler or micro sprayer system, wind will be a factor, and it could be a critical factor if you don't select the right product on the windy area. Another important condition that every field it's different. It's obviously the soil structure and the infiltration rate. So based on what type of soil you have, some soil will infiltrate water faster than others. So if you, just an example, if you don't take this in consideration and you design or install an irrigation system that is gonna apply water in terms of inches per hour higher than the infiltration rate, the soil, it won't be able to absorb that water fast enough, and some of the water that you are applying actually is gonna be running off on the field. Okay? And the soil structure, I meant that, and this is more like in practical terms, when you are planning an irrigation system, you have to decide many components, what kind of materials you want to use. For example, if the soil is really rocky in some areas, and you think it's going to be really complicated to put something underground, so make a trench to put your pipe there, you may be considering to run some areas of the system above ground, and that means that you have to, based on that information, you have to select the right material for that pipe. That shouldn't be, for example, if you're going to put above ground, it shouldn't be PVC pipe. It should be more like an HDPE or polyethylene based product. So that's a factor for you to consider. Water table level, very important as well. I mentioned it here because we're talking about irrigation. Sometimes people, and it's not that common, but it's in some areas it is. In Okanagan, the water table level is high. And one of the irrigation is one of the more important factors that you, as a vineyard farmer or grower, has as a tool to control the quality of your grapes or berries by controlling how much water you're going to apply and when you're going to apply it. If you have a water table level that is too high, so that means it's too close to the ground level, you may lose that. Because even though that you may manage the irrigation in a way that it won't apply water in the period that you want it, the roots still may be able to get that water from the ground. So how you deal with that? Well, there are different ways. You may even have to put some sort of drain system if you really want to go in that direction, but it's a factor that you have to consider. Okay. And important as well, and this is more like in the cost part of things, it's important to know what kind of energy you have on this field that you're trying to irrigate. If you already have power, electric power there, and you're going to require a pump, that's a great news. If you're going to require a pump and you don't have electric power, that's a really bad news, because now you have to either bring it from somewhere, which in terms of cost will be high, or options like a generator or something in that line that will require or reduce your opportunity to make it automatic, this system, because you have to put diesel or gas or propane or something to that generator that you're going to have inside. Okay. So again, here are a couple examples why it's important to know the field conditions, because I just put two examples there. On the left-hand side, you can see that basically that's a 3D representation of one real field that we designed. It's kind of notorious when you see it on 3D, what's the difference in elevations on that field. So if you don't properly take in consideration that topographic situation, you may end with a lot of water, which is the blue area that you can see in the lower part of the field, and you may end with not enough water in the red part, which is on the top. So it is an important factor. On the right-hand side, you can see it's showing you that in a windy condition, so if you have an area and you're working in an area that you know it's windy, if you put the wrong emitter, for example, that is not designed, by wrong I mean it's not designed for windy conditions, the performance, it still is going to apply the same amount of water than the one that is designed for wind, but the uniformity is going to be really low because the performance, it's not designed to fight the wind, let's say. So as a summary of what I just spoke so far, you take those three basically parameters that you have, which is basically now you know, you answer, I do have water, and you know all the details about what kind of water source you have. You also answered that you know what's going to be your annual infiltrate irrigation needs, so you know how much water you need, and you also know the field conditions. You can feed a professional irrigation design with all that information, and the result of that is going to be that you're going to have a system from day one. And this is the important part. This is why it's so critical, this to me, is that if you do all that part on the planning and you run it through a professional irrigation design, for the next 20 years or whatever is it, like lifetime of that vineyard, you're going to have a system that's going to be working with high uniformity. You're going to have a system that's going to be efficient in terms of how you use the energy and you use the water. It's going to be relatively low maintenance. And what I mean by that is because that means that if you did all these steps that we just talked, you have the right filter for the right water quality that you have there. So you probably don't have to over maintain a filter that is not designed for the conditions that you have. And all that is going to reflect into low operation cost. I'm saying it's critical because it's if you don't follow all these steps, you may have an irrigation system that you have to, over the years, have to always retrofit some solutions in terms of automatic system, in terms of filtration, in terms of maybe change even the meters. And all that is happening because you didn't plan from the day one. So you have to deal for the next 20 years with how we solve these problems that we have here, that in essence we created, but by not planning this properly. Okay. Now moving more into the technology part of things, and just to summarize this, all what I'm going to talk about, how you properly start designing that system. You can take advantage of technology. There are some cat irrigation software, and they are not unpopular, and they've been there for 15 or more years, so it's not new technology, but not everybody knows that it's there. Those cat irrigation softwares give you many advantages when you are planning your system from beginning or you're replanting, which by the way, if you have to replant your field now, which obviously nobody wants to have to do that, but also you have to see it as an opportunity that if it was something that wasn't working well before, now is the right time to change it. Okay. So the CAD software, it will take in consideration all those factors. Well, you have to fit all those factors that we just talked, and as a result, it's going to help you to produce really quickly and really accurate hydraulic calculations for every point of your field. It will allow you to actually simulate. This is the thing that I like the most about this technology. It's you can, if you have 3 or 4 ideas on how you want to plant it and where you want the valves and should we run this direction or the other direction, the rows, you can use a CAD software that can run many scenarios really fast, and it will give you results right away on terms of, it's going to tell you what's going to work well on that scenario and what's not going to work that well. That's the scenario. So it helps you to really decide what's the best option. It also shows you what's the flow and the pressure in every point of the field, which without software, you can design it. There are ways to do it without a software, but it won't be fine enough to give you that information in every point. And it will take in consideration the field conditions, topography, for example, and you can easily feed it into these softwares. So they will take that in consideration on the calculation. And at the end, the software is going to provide you an accurate installation map. It's going to provide you with all the calculations, going to tell you what size you should have everywhere to make that system efficient in terms of use of energy and also uniform. And it's going to provide you a pretty close estimation of the materials that you need for that project. Okay. I'm either a really good teacher or I hope you are still listening what I'm saying. Okay, I just don't see your faces. So now I'm gonna move to, since you are planning your new vineyard, it's also a good time to plan not only how this new system is gonna look, this new irrigation system is gonna look, but also to plan what kind of technology you can apply and what you could do in this installation process to make easier to include or add technology to your field. Okay, one common, which is really common, it's not new, it's been there for years and years. One common addition that you do to your system, it's weather stations. The idea of the weather station is, as I mentioned before, you can get information from public weather stations that they may be close in terms of distance to your field, but they never ever actually are exact, like how more exact than if you have a weather station in your field. And I tell you this by experience. I've been working with these weather stations for over 10 years now. And we have fields where in the same field, we have different benches. We have weather stations in those different benches, independent ones. You will think, because by the distance, you probably are only like, I don't know, 500 feet away or 1,000 feet away from one bench to the other, you will think that's going to be similar, and actually they are not. They are really, really different between one to the other. So I'm saying it's good to use the tools I mentioned before if you don't have the technology in your farm. But it's also, you have the opportunity to add it, it will give you a better result or better information, which basically means better decisions in your farming. So what I put here is just a screenshot, different weather stations. There are different technologies out there. Different weather stations are going to give you different information, or the format's going to be different, let's say. But in general, on a standard weather station, it will provide you air temperature, it will provide you relative humidity, it will have a wind speed direct and wind direction sensor, and also it's going to have a rain gauge. That will be a standard weather station. Also common that you add on top of that solar radiation sensor. The idea of doing that is that with this technology, you can have actually the software to calculate some parameters for you. For example, we were talking about evapotranspiration. If you have the solar radiation, the relative humidity, and the temperature sensor, you can have the system to calculate that evapotranspiration or estimate that evapotranspiration for you daily. So that will be a really good indication coming from your field on how much water you should be applying on your irrigation sets. Also, wind speed, wind direction, very common use for spraying purposes. Sometimes your field is not close to where you live, and you're planning to do some spray application, but you need to know if you have wind or not there. Since most of this technology send the information remotely, so they send the information to the cloud, so you can access from your phone. You can actually, before you go to the field, you can check if the wind conditions are okay for spray, or if you should be doing something else that day. Okay. Now, in terms of this same technology, and I just put pictures here based on what I have I could find on my files. So I'm not trying to put any brand or anything. I'm just trying to put the technology here. In this case, the same technology that will give you, it will give you information about your weather station. It can be connected to the irrigation. I put a couple pictures. These pictures are from Southern Canada, actually. The first picture shows backflow preventer and a filter connection, where they add a flow meter, I mark it there, and they add a pressure sensor, a pressure transducer to the main line. So now they can actually keep record of the water that they are using. They keep record when they are using that water, and how the pressure is moving while you are running the irrigation. This is very important because in many systems that you may have just a normal controller without telemetry. In a normal controller, I mean a controller that's just going to open and close valves. You may do your program. The controller may tell you, yes, I did run all the valves, but how do you know actually if the water got to the field? Not uncommon if you work with irrigation systems with controllers, the solenoid in the valve failed. So the controller is telling you the valve number 3, it did run because the controller sent the power to run it, and you assume that it ran, but actually that valve 3 never opened, or the water really never touched the ground. By having a flow meter and a pressure transducer, you can actually track that. Okay. On this picture, in this particular system, they have a telemetry unit, which is the green box. And that green box, it will be sending all the data to the cloud, and also it's going to be sending the commands from your phone to the controller to open and close valves. And the box on the stainless steel material is actually a controller, and they both are talking between each other. So the green box or the telemetry unit, it will be telling the controller what to run and when to run it. Okay, the picture on the right, it shows you how looks that connection, how the valve looks connected once you are in the field to have it running through a telemetry system. What's the result of this in terms of information? What I just described there, you can see it in this graph here. What you see in green color, the graph of green color is the flow meter readings. On the middle, and you can see it says close and open. That's actually which valve is running when it's closed. Close means it's a number, it's up. Sorry, open is up, or number 1 if you want, and then close is 0. And then the lower graph shows you the pressure in the main line. So if you see, if you can see the one in the, like there are 3 flows events here. You can see there are 3 irrigations. I don't know if you can see. Can you see my mouse or not really? Okay. If you don't see it.
Yes, we can see it, Herman.
Okay.
Yeah.
So I'm going to focus on this point here. Okay. What this is showing me, this area, is showing me that this valve, which is, let's assume is valve number 1, the red color valve, it went on at this time. By the way, if you are looking on the right, on the real software, you can actually go exactly to the time when that valve went on. And I can see that went on here. As soon as it went on, we jumped from 0 gallons to around, I don't know, 90 gallons per minute, I would say. And also the pressure, as soon as that went on, it dropped. So I have 2 confirmations that the system was running. I had to 3. The controller is telling me that the valve was electrically on. The flow meter is telling me that the water actually was running, and the pressure is telling me that there was enough pressure to run, and it drops from that period of time because you were running water. Then you can see, I'm gonna keep looking here on the pressure part. You can see when valve number 1 ran, then when we went to number 2, which is this green one, it drops even lower, which basically means, and this you can confirm it, if it drops lower on pressure, means that you are using more water, and the flow meter is showing me that. So in other words, block 2 is bigger than block 1. I can tell that here. And so on. It's basically showing me every single valve that was running, when was running. Interesting enough, if you're looking on this, you're gonna notice that from this valve on, the flow is 0, even though that we have valves open, and the pressure stay constant high. So what really this graph is showing me that I did open all those valves, but no water was running anywhere, and no pressure was, and the plumbing wasn't in high pressure, which confirms that there's no water running anywhere. So this information, as you can see now, is really useful in terms of know how the system is operating and detect if something is not working properly. You can set the system also to notify you when situations like this happen, so you can have a rule on the system saying, if a valve is open, the flow is 0, then I need to have a text message or an email or even a phone call to somebody. Or if the pressure is too low, if the valve is open, but the pressure, let's say, is 0, which means you really don't have pressure to run the irrigation, you should have a notification. That's how this system will do that, or telemetry system will do that for you. I know I'm running out of time, so I'm gonna go really quick to the last technology that we use. And another factor that you can track with telemetry system, you can track actually the soil moisture that you have in the soil. This is a typical graph of a multi-level sensor. This is a multi-level probe. It could be like 1 meter or something like that. And you have 6 sensors on different depths. And you can tell here, the blue sensor, I know it's 10 centimeters. This is telling me when it goes up, that's when the irrigation starts. It's telling me that also, if I keep in this one, it's telling me that the green sensor, which is the second sensor, 20 centimeters depth, it went up, which means the water is reaching there. Then the next one is the red one. But if you see the red one, actually, it didn't move up. It just kind of stayed flat. What that's telling me is that whatever is the length of that irrigation set that I'm running is not getting the water to 30 centimeters. Got it? So information like this, and you can see in the long term, the 30 centimeters, they hit it in this stage of the season, at the very end of the season, really. So the idea, technology can help you. If I can send you a message before I finish here, is like technology, it's there. Technology helps you to know how good your system is working. Technology helps you and take decision on when you should be irrigating. But the more important thing is technology is not going to do that by itself. You need to use it. And I'm saying that based on, it's not about how advanced is the technology that you have there. It could be actually their systems are less advanced. That still could do a big impact in you if you use it properly in your irrigation practice. Okay. So, Kate or Kathy, I think I'm almost on time.
Yes, we've got time for questions, which is awesome. Okay, I need to open my screen. Pop questions into the chat if you have any questions. I think I have a question. So a lot of vineyards are in position to be replanting after the cold event. So, and you know, some of these vineyards are 20, 30 years old. So what should they be looking at in terms of upgrading and sort of repair while they're pulling up plants and maybe reconfiguring the vineyard? What sort of irrigation considerations should there be?
Well, like I say, that's a good question. As I say, I mentioned it somewhere there. I see it as an opportunity right now. If you have a vineyard that's been there for 10, 20 years, at this point, I'm pretty sure that you know that vineyard pretty well in terms that you notice that maybe some areas got more bigger than other areas, for example, right? Normally that means that for different reasons, maybe you are applying more water in some areas than other areas, whether it's the sprinkler or the meter, it's not done properly, it's not designed properly, whether it's the soil. But this is the days like that, you should be considering now that you are replanting, because now is the right time to correct that. So basically, you need to identify why that area is getting more or less water. Once you identify the real reason of that, you can incorporate that on your new design for your irrigation. So you don't have to have the same problem the next 10 or 20 years, right?
So RDV imaging would be useful for that, right?
Sorry?
Is that what you call it? RDV imaging? Like aerial IR?
NDVI?
Okay, that.
Yeah, NDVI. So you're talking about satellite pictures or drone pictures.
Drone, yeah.
Exactly. Yes, that's a good question. I was thinking and put one of those here. Yes, that will be good information for the people that is not familiar in this group here. It's basically image that they are infrared, they read infrared. So it may identify areas of your field that are either too dry or too wet. So you say that would be a really good information to have on hand if you're replanting, because now you can really tell what wasn't working perfectly before.
Right. Yeah, like, I mean, we've always had, of course, our vineyard's on a hillside, and we've always had issues with the bottom couple of panels having more vigorous growth, right? Because as you said, water runs downhill. And there's probably new strategies to keep that from happening with drip, right?
That's right. There are a few different options. And you have to find an option that is practical, because I mean, you can go to the option that you can have every row different, but it's really hard to fine tune and maintain that.
Yeah.
The strategy normally that we take in those cases, it will be to make the length of the rows, even let's say the row it's 500 feet, just to say something, and you're seeing this problem on the lower 150 feet or 200 feet. So we tend to do a design when we have a slope like that, that's gonna break that 500 feet in two sub-mains. So now you can run different times on them, basically, right?
Right. right.
So, but that's a good point. Exactly. If you notice that there are options to solve that, but this is the time to find what is it, right?
Yeah. So, I mean, there's got to be a cost associated when you add zones, right?
Yeah. Well, yes, but there's it depends. That's one point that you can go really fine and do it in every single lateral, which
Yeah.
means you will have 40 valves, for example,
Yeah.
which could be not practical, right?
Yeah.
So the happy medium, in my experience, it will be you just divide blocks like the lower blocks, you separate it from the upper block
Mhm.
with just two valves, so you are adding an extra valve.
Mhm.
If you do it in that way, yes, you're right. It's going to be an extra cost for an extra valve or an extra pipe. But if you take in consideration that that's going to solve your problem for the next 20 years,
Yeah.
actually the cost is paid really fast.
Yeah.
Right?
And there's no, yeah. How do you put a cost on quality too, right?
Exactly.
Yeah.
Mhm.
So Reto has a question asking before I actually say this question, I wanted to point out that like we've applied for an IAF grant that would cut under their water grant intake for that will hopefully cover the cost of the weather station and with the soil probes, et cetera, et cetera. So, and so to that point, Reto is asking what kind or brand of weather station are you recommending for temperature and soil moisture?
Okay, before my answer will be, it really depends on what you are looking for. And what I'm going, you can go from a really an expensive weather station that it may, if it's close enough for your house and you have a house there, it may just transmit the information directly to your house by, wireless. And that would be a really expensive solution, but you may not have access remotely on your phone to see it, for example.
Yeah.
So if you go in that direction, I mean, there are different brands out there of the equipment itself. Davis is a really common one to do something like that. But now, again, that will be less expensive, but it won't give you remote access to that information. Or also, it's not gonna calculate for you some parameters like growing degree days and evapotranspiration. Now, if you want to go to something more advanced, I will go with telemetry system. We in general, we use Ranch System is one company that we've been using in this valley for 12 years, and it will do that. It will basically cover everything what I just showed here. But there are other companies in between as well, right? I would say my best advice is first, you don't let technology to tell you what to do. You tell technology what to do.
Right.
So what you really want, I just want to have the temperature and read it every morning. You can go with something not so sophisticated, right?
Great. Great. Gil Costa is asking, should irrigation blocks need to be designed around soil type, texture, and water holding capacity? We did cover that. And also he's pointing out that Verity.ag is a great automation and monitoring system.
Yeah. So yes, I mean you should design based on soil, all the factors I basically just mentioned there, really. So you should design it based on soil types. Now you have to find again the happy medium between what you commercially can do and what you can commercially not do. So if you have 40 type of soil in a 10 acres, you probably cannot do 40 different blocks there. I mean, you can, but I don't know you want to get there. My best advice will be you will separate, in my experience, I will say design the system based on main soil types I can see there, 2 or 3 of them. I will separate it on main topography changes that I may see there. And then a common, this is actually a practical, which is technology too, but irrigation, it doesn't involve anything electronic. A common solution for areas you may have a pocket with rocks in one area. You just do small blocks. If you cannot separate that block itself, you run the water until when you identify exactly the area that it's drying faster. And you can, for example, and you plan it on the design part, you add more drippers on that area or more sprinklers or whatever on that specific area.
Right.
So that's a way to manage those changes, because many times, even if you plan it perfect, you have to wait a year or two to actually identify a couple areas,
Yeah.
right?
Yeah.
Mhm.
Yeah. We had that situation when we switched over to drip, and because we have these sand lenses through the vineyard, and so we had to double up the drip in those areas, right?
Yeah.
But yeah, it was quite effective, and it's worthwhile to do. As a
Yeah.
winemaker, I can tell you it's really worthwhile to do it, because consistency is everything. So it's really, really hard to assess ripeness and that sort of thing if the vineyard's
That's right.
not
And
consistent.
if I can add, actually, this is not new in the valley. There, especially companies that they are shooting for really high quality. There's some system that from beginning they have actually two drip systems. So they have the normal drip system that you have. We have a second sub main, which is run with a second valve, so it's completely independent. But they don't put that drip line until a year or two once you identify the
Right.
areas that need more. So now you can run the normal irrigation and you
Right.
run the extra half an hour or whatever you need on that point, right?
Well, and also the roots are reaching deeper as they're older, right?
That's right.
So yeah.
So that's common also, like have a double drip system in the same block. Yeah.
Okay, so everybody, that's how you make premium
Yeah.
wine. You put more money into it, but it pays off, right?
But it pays off because it gives you quality. That's the point. Yeah.
Exactly. That's what we're here for sure.
That's right.
Okay, I'm gonna wrap it up. I accept that Gil has just commented. A lab analysis of particle size distribution and water holding capacity helps in determining your irrigation thresholds, as well as in regulated deficit irrigation starting at Barahona. So
Yeah.
comments. So thanks everybody for coming. If you'll be able to watch this presentation again in the future, Kate will put it up on the website, and tell your friends it's available, especially if they're designing a vineyard or replanting. And thank you, German. It was super interesting. This website, the agriculture water calculator, it's very cool.
That's a very good one. It's a really good resource. So you should be playing with that a little bit.
Yeah, it's very robust. Yeah, like you could design a game around it, I think. So our next meeting is Thursday, the third Thursday in August, which is the 15th. And we'll have Dr. Mehdi Sharifi from the research station updating us on the work that they're doing on cover crop decision making. So also really pertinent when we're looking at replants, I think. Thanks again, German.
Thank you. It was a pleasure. Thank you for reminding me.
Then
Thank you.
thanks,
Thank
everybody.
you.
Bye.
Bye.
Thanks.
Yeah.